Good day, class. Today we are going to learn about DC machines, direct current machines. The word machine stands for a man-made apparatus or a man-made device using mechanical power to perform tasks. At the end of this lesson, we will be able to explain the function of a DC machine. We will be able to explain the construction of a DC machine, and we will be able to explain the significance of back EMF in a DC machine, and we will be able to calculate the back EMF in a DC machine. Like we said earlier on, machines help us to carry tasks more effectively, more efficiently, quickly, and profitably. We've got two types of machines. We've got a machine that converts electrical energy into mechanical energy, and we have a machine that converts mechanical energy into electrical energy. A machine that converts electrical energy into mechanical energy is a motor. I repeat, a machine that converts electrical energy into a mechanical energy is a motor. And a machine that converts mechanical energy into electrical energy, it's a generator. I repeat again, a machine that converts mechanical into electricity is called a generator. These machines have got the same operating principles. They also have the practical looks, their appearances are the same. We use these machines for printing processes. We use them for geared lifts. That is the lifts that has got gears. They change gears, geared lifts. We use them for hoists to lift heavy stuff up the tall buildings, for conveyor belts, for conveyor stairs, for conveyors. We use them for lathes, for pumps, for compressors, for drilling machines, for milling machines, for cranes, and for winches. Let us then have a look at the physical construction of a DC machine. That is, let us have a look at the constituents of a DC machine. You will notice that there are two main parts of this machine. There is an outer casing and there is an inner part. Now look at the outer casing. The outer casing is called a yoke. It is a steel frame. It is made out of a ferromagnetic material. This material here is a ferromagnetic material such as mild steel, cast iron, wrought steel, or it's an alloy of a little carbon and steel. That is the casing. And when you look at the casing, you'll notice that it has got four legs. 1, 2, 3. Because this internal part, let's name it first. The internal part, this one is the one that rotates. That's why it is called a rotor. It rotates. It's a rotor, or it's an armature. It is armed. Armature, armed. It is armed with conductors, mesh of conductors. So they call it an armature. And on this armature there is a shaft here. This is a shaft. The purpose of the shaft is to suspend the armature onto the housing, the frame. That is this frame of the machine, to suspend it so that it can rotate freely. Okay, so we've got the casing, which is the yoke, and the yoke is made out of cast iron or wrought steel or wrought steel, or I mentioned earlier on, it is an alloy of a little carbon and steel. It is a ferromagnetic material, right? The next step, inside, let's go to another slide. You'll see inside here, on the casing, you'll notice on the casing, this casing that you see on top here, you'll see inside that casing, there are poles. We've got 1, 2, 3, 4. That is, if you are looking at this machine from this angle here, it looks like that. And it shows you 4 poles. 1, 2, 3, 4 poles. And we can still say there's 4 pairs. There's 1 pair, 2 pair. Right. Now, the poles are mounted, they are mounted here. They are mounted onto that casing. They are mounted somewhere in here. When you check, you'll see they are mounted onto that casing. And then mounted onto these poles here are pole shoes here. Are pole shoes. The pole shoes. Now, the purpose of the pole shoes is to hold. The purpose of the pole shoes is to hold these coils here. You see, you'll see here there is a wire, a copper wire that goes there. This copper wire is laminated with varnish, laminate copper wire, and now it is wounded. There is a winding here. You'll see there's 2 windings. You wound it around. You wound it around the pole, 3 windings there. You wound it around the pole, 2 windings. You wound it around the pole, 3 windings. So now the purpose of the poles is to support the windings, and these windings are called field coils. They support the field coils, and at the same time the shoes are used to hold these wires firmly so that these windings don't fall down. Is to hold that. The purpose of the pole shoes is to hold the field windings in position. Okay. Now the responsibility of the poles is for the production of magnetic flux. Let me say, on a permanent magnet, you know there is a magnetic field. So because these poles are now going to be electromagnets, they will then induce or give birth to magnetic field. And there's a lot of lines. You see these lines here with the arrows, these lines here with the arrows, they represent magnetic field. But because there's many of them, we then call them magnetic flux or flux density, right? So there's magnetic field. So the purpose of the poles is to produce magnetic field. Strengthen the magnetic field, increase the efficiency of the magnetic path. As you can see, let us have a look at this one here. You'll see there is a line here. It flows through, it goes through our armature, and then it goes back again. So that is a path. We call this a magnetic path. Right. Going back to our previous slide, where we had a rotor and the frame. Now, our rotor, we said it is armed with conductors. We call it an armature. Now, this armature that we are talking about, let us have a look at its core, the core of the armature. The core of the armature consists of plates. It is made out of plates. We've got a slide here that will show us the core. If I can get that slide. Let's go to the core. We've got a slide that shows us the core or the blades. Sorry about that. That's fine. Now, here is the core of the armature. The core of the armature is made out of different blades. You'll see these are slices of blades. Blades I've got a diagram here of a transformer that we've learned about previously. Look at this transformer. You'll see that the core of a transformer, this is a solid core, laminated core of a transformer. It has got blades, thin slices of blades, laminated blades, thin slices. Even the blades of our armature core are the same as this. They are laminated, but the shape is different, but they are the same blades. When we talk about blades, we're talking about that. So this is the core of the armature, and it consists of a lot of blades put together to form a solid thing, but they are insulated in the middle. What is the purpose of the blades? The purpose of these blades, remember, when you go to your first slide, the armature rotates, and as it rotates, it heats up. So the purpose is to cool it down and also to get rid of eddy currents. These conductors that are here on the armature, they carry current, and that current now will induce a current into these blades. So the purpose of the blades, or the current into the core, the purpose of the blades is now to reduce the eddy currents that is flowing between plate 1 and plate 2, plate 1 and plate 2, like that, like that. Okay, let's go back to slide number 2. Now, we were talking about the poles. Let's go a little bit to our poles. Our poles are also manufactured the same way as the armature core. Our plates, the poles, we've got plates, a lot of plates, laminated plates. They are put together to form a pole. Now we know the purpose of the plates is to help for cooling down and to get rid of eddy currents. They are riveted, as you can see here, riveted holes, right? And then we said that when we started, we said that the purpose of the poles is to hold the field coils into position. The purpose is to hold, look at this diagram here, is to hold the field coils into position. But when you look at this edge here next to the shaft, the conductors are visible. But when you go to the middle of our armature, you don't see the conductors. What's happening to the conductors? These conductors are embedded into slots. We've got a slide that shows us the slots on the armature core. Look at the shape of that core, the armature core that I showed you. Armature core. Sorry for that. Right. Look at this. You'll see, look at the shape. It is shaped in a funny way, but it has got some corridors here, some passages here. There is a subway. This is a subway. This is a subway. This is a subway. This is called a slot. Slots are manufactured here, and these slots are used to house the armature conductors. So the armature conductors are going to be embedded in here. Going back to this slide here, look at the drawing I've got here. This is our armature core, and then the armature core consists of slots here. Now inside the slots, you'll see I've got 1, 2, 3, 4 conductors. These 4 conductors are flush with the surface of our armature core. In a way, using a layman's language, they are hidden inside the body, inside the core of our armature. They are not protruding to the external world. Remember, when you look at the first diagram, the pole shoes are running here. The pole shoes are here. So therefore, they shouldn't be a collision or an accident or hindrance between the armature conductors and the shoes. Okay. right? So we've got slots, and in the slots we've got armature conductors, and this is the armature core. Okay. Lamination is used on these plates to make sure that the plates don't cause a short circuit, and it is also used for cooling down the core of the pole or the core of the armature core. All right, let's proceed. Sorry for the delay. Let's go to the slide where we are going to talk about the field coils and the armature coils. Right, this one. Let us summarize here what we've got. We've got wires that are terminated to the external circuitry here through this terminal box, and then these wires are coiled around a pole, another pole, another pole, and another pole. When you look at Lenz's law tells you that around a current carrying conductor, there is a magnetic field built. So therefore, around these conductors which are carrying current, magnetic field is built, and then the purpose of the pole is to strengthen the magnetic field. Point number one. Point number two, the armature also has got a core, and it has got conductors, armature conductors. And also it is connected to the external circuit. Our armature conductors are connected to the external circuit via, there is a port here. There is a port. This port is called a commutator. It is called a commutator. Let's go to a diagram that will show you a commutator. Right. On our diagram, this is the armature, and the armature consists of armature conductors. There they are. And then it consists of slots. When you look at this here, these are your slots. And all of these armature conductors are hidden inside the slots. They are inside the slots. You can't see them. This is the top of our slots. The bottom of the slots, remember earlier on I said they are corridors? They are buried inside the slots here. They are buried inside the slots. But the end, the starting and the ending of our conductors is now soldered onto plates here, copper plates. These are different copper plates, and between the copper plates there is an insulation, a gap. Inside this gap there is mic. This will say a copper bars, is a bar, but they are circular. They are circular. Let me take you back to our first slide. When you look at the first slide, the second slide, sorry, I beg your pardon. The second slide will show you our commutator, which is balanced by, here we are. You see, this is a shaft here, and the shaft goes through, and the commutator, here is the commutator. See, the commutator sits here, and then the contact for these conductors here, the armature conductors, to the external circuit is through the brushes. So the connection is through the brushes. It is not a solid connection, it is a friction-based connection, rubbing two surfaces against each other. So 1 minute this brush is on this copper bar, and the very same minute this brush is on another copper bar. So as it spins, it exchanges the copper bars. Okay, right. So the contact with the external circuit is through the brushes. Let's see, we've got another diagram that will show you clearly. Right, this is what I'm talking about. You notice here we've got our armature. We've got the armature, and these are the armature conductors embedded into slots, and the end of these conductors is soldered or welded onto these copper bars.